Welcome to Study Loop.
We're working on a half-life problem, and we know the half-life of the substance is 5 days. So if we start with 200 milligrams, 5 days later there's half of it, so there's 100 milligrams. 5 days later there's half of that, 50 milligrams, and 5 days later half of that. So when 15 days have elapsed, there are 25 milligrams left. So that's the answer for part A. For part B, we want to generalize, so let's look at what's happening so that we can figure out how many milligrams will be left when T days have gone by. So we started with 200, and then we multiplied 200 by 1/2, so that could be considered multiplied by 1/2 to the first, and then we multiplied it by 1/2 again, so we multiplied it by 1/2 to the second power, and then again, so we multiplied it by 1/2 to the third power. So what we can see is the exponent here is the number of days divided by 5, the number of days divided by the half-life. So if we generalize that, we could say that if T days have gone by, we have 200 times 1/2 times the number of days divided by the half-life. And that gives us our answer for part B. Remember that T is in days. Now we're going to use that as our formula or as our model, and we're going to find the estimated amount of bismuth 210 left after 3 weeks. So 3 weeks would be 21 days. We need to convert to days since this whole problem has been done in days. And then we're going to substitute 21 into our equation for T, and then we'll put it in the calculator and we get approximately 10.88 milligrams remaining. Finally, we'll use a graphing calculator and we'll graph the function that we found, 200 times 1/2 to the x divided by 5. And we'll also graph the line y equals 1 because we're interested in finding the time it takes to get down to 1 milligram. So the line y equals 1 will represent 1 milligram. Then for a window, I've chosen to go from from -1 to 80 on my x-axis and from -1 to 50 on my y-axis. And you just choose some numbers and fiddle around with them until you find what you like. Now we'll graph that. So here we see the exponential decay curve that represents the half-life. And then we see this red line at the bottom. That is the line at a height of 1. That's 1 milligram. And we're interested in knowing that point of intersection. So we can go into the Calculate menu, choose number 5, Intersect. Put the cursor on the first curve, press Enter. Put the cursor on the second curve, press Enter. And then move the cursor over to the intersection point, press Enter. And what we get, you can see at the bottom of the screen, is about 38.2. So that tells us that it takes about 38.2 days for the substance to be down to just 1 milligram remaining.